Okay, cool. What do we got tonight? Hold on one second. Sorry, I gotta turn my drawing pad on. All right. Okay. Okay. Okay, that's trig. Yeah, it's called the sinusoid function. Let's talk about the sinusoid first. You have some problems? In other words, the sinusoid function takes the form of right? That there actually are three different ways that are the general format. So I want to make sure we're talking about the same thing here. Is this what your general form is? Okay. So if I give you a function such as this, you know what A is, right? Notice what that also is. It's a vertical stretch factor, right? In other words, if you think of this trig function in the same way that you look at algebra functions, all of what you learned as translations are exactly the same. Notice where I've written x minus pi. That's a horizontal translation, is it not? It's just in the sinusoid function, they call it a phase shift. And I'm assuming you've dealt with all four of these variables, A, B, C, and D. Okay. They call that a phase shift, right? 7 is called a vertical shift, just like it is. Everything's the same. 2 is a vertical stretch. 3 is a horizontal shrink. Pi is a horizontal shift to the right by a pi amount. And 7 is a vertical shift. So, if I were to take a sine function, that is just strictly y equals sine x. In other words, a is 1, b is 1, c is 0, and d is 0. You got me? Okay, now let's apply each of these translations. Let me change colors so I can do them one at a time. The blue one, I'm going to apply the 2. What did I say that was? A vertical stretch factor, right? That's what that does. Okay? Now, I'm going to apply the 3. Different color. What's the 3? Horizontal compression, right? So the ending point, instead of being out there, it's got to be about there. So I've got to draw the sine curve in that tiny little spot. That's taken into account the 2 and the 3 now. Third, the pi is a horizontal shift. Which way? to the right. Okay, by pi amount. So I'm going to take this green curve, shift it to the right by pi, looks something like that. Okay, you with me? These sinusoid things are exactly translations. I don't know why they confuse the student by calling them otherwise. And now the last thing to do is to move that orange curve up 7 units without changing its shape. And that's how you do it. Now, they expect you to be able to go both ways on this thing. In other words, if they give you a sinusoid function, they expect you to be able to graph it. Or if they give you a graph, they expect you to be able to come up with the sinusoid function. So let's talk about that for a second. Let me get rid of this. Unfortunately, that's the one downside of online tutoring, is I don't have a big enough whiteboard. I see these TV commercials where the professor is on this ladder and he's got this giant blackboard that he's writing on. And I understand it now, why that's needed. Okay, let's even erase that. Let's say, let's start with the function. I have given you a sinusoid function. You know A is 2, B is 3, C is pi, and D is 7. Okay. Let's take the normal sinusoid function, y equals sine x. Let's put some dimensions on it. It goes from 1 to -1. And out here is 2 pi. Right there, that intersection is pi. That bottom point is 3 pi over 2. And that maximum point is pi over 2. Okay? So, let's say they gave me this graph, and I wanted to know what A, B, and C is. Hold on a second. Let me just, because that's the way they do it, is they give you a graph. Not this simple. I'm giving you the simplest case. But what you try to do is figure out A, B, and C, and D from the graph. So let's see if we can figure out. What's the formula for figuring out A? A being the amplitude, right? What do we see the A? What is A here? Just looking at the graph. Is it 0? Is it 1? Is it 2? Is it 3? What is it? Well, the amplitude is this amount right here, between there and there. And it turns out that it is the maximum value minus the minimum, excuse me, the amplitude is from there to there, from top to bottom of the graph. Okay, that's a +1. Okay. The way you come up with A, which is the amplitude, is you take the maximum value, subtract the minimum, divide by 2. So what do you get? What do you get? I was right the first time. Sorry for confusing you. Hold on 1 minute. Let me just erase this. The amplitude is from the x-axis to the peak. So we know the amplitude is 1. And here's how you get it. You do the max minus the min divided by 2. Well, that's 1 minus a minus 1, which is 2, divided by 2. So the amplitude is 1. And that's what A is. The next easiest thing to get is D, which is the max plus the min divided by 2. What's the max plus the min? Plus the min? It's negative 1. In other words, yeah, here's the max, there's the min. That's what I mean by the max and the min of the sine wave. So what's the max plus the min divided by 2? 0. Okay? What that means is there is no vertical shift. Our horizontal axis of symmetry is the x-axis. This curve has not been shifted vertically up or down, correct? We can see that. It's symmetrical somewhat about the x-axis. I'm going to give you a harder one here after this one, but you're going to get the hang of it. B. First of all, you have to memorize this. B equals 2 pi over the period. You've seen that before? That's familiar to you? The period is the point from where the graph starts to where it gets back to the same point. In other words, this graph actually looks like this, okay? So the period could be measured from there to there. The period could be measured from this point to this point. See what I'm doing? In other words, you want one complete period before you start over again and repeat. So what's the period here? It's 2 pi. 2 pi. In other words, it's the distance between that point and that point on the x-axis. That's 2 pi in this case. So, if the period is 2 pi, what is B? Okay, so I'm going to go over here and I'm going to fill out B. Now, the phase shift, it stands for 2 pi over the period. That's what it stands for. It happens to be a horizontal compression factor, but a better way to think of it is 2 pi over the period. In other words, memorize this. You're going to need it. Every single time you address one of these problems, you're going to need that. And also, if B equals 2 pi over the period, then the period equals 2 pi over B when you're going the other way. Okay? Both of those things in the upper right, you need them. You only need to memorize one. If you can memorize one, then you can solve for the other. All right. So we have figured out what B is. In other words, ultimately, we want an equation like the equation right here, only with a correct A, B, C, and D. Well, we've solved for A, we've solved for D, we've solved for B. The only thing left is C. That's going to be a little bit harder to explain, but for starters, let me just tell you that this has not been phase shifted. This is the sine curve without a horizontal translation. You with me? So C is 0. There is no phase shift. There's no horizontal shift. Okay? So now we can write the equation of this thing. What's the equation? Y equals, well, A is 1. So it's sine, what's B equal to? 1. X, what's C equal to? 0. What's D equal to? 0. There's our equation right there of that curve. Now let's go through just a slightly harder one. I'm going to draw the curve. I think this is the best way to teach this, is to draw a curve and then come up with the equation of that curve. Only this time, I'm going to have it go out to just pi. In other words, I'm going to horizontally compress it a little bit. Then I'm going to go up to 2, down to 2, to minus 2, excuse me. And I'm going to make the whole thing look like this. And the question is, what is the equation of that curve? So, what do we start with? We start with our general equation. With me? And we figure out what the letters are. What is A, B, C, and D going to be? Well, what did we say A was? A was the minimum minus the maximum divided by 2. What is that in this case? So that's A. D is the next easiest thing, because that's the minimum plus the maximum divided by 2. What's that? Okay. In other words, there is no vertical shift again. Now let's figure out B and C. What is B again? Defined as? Yeah, 2 pi over the period. Now, I made a mistake when I drew this. I didn't mean to draw it quite like this here. Let me change this by just shifting the pi. I meant to have the pi at the end. So, let's make this pi right here. You with me? So what's B? Two pi over pi. What is that? Huh? No, it's pi. Oh, no. It's 2. Sorry, I hadn't written it out. So that's what B is. We've solved for A, D, B. What's C? Has this thing been horizontally shifted? So C is 0. So tell me the equation of that curve. Now, this is important. The two needs to be outside the parentheses. In other words, if there was a phase shift, that's how I want it to look. Okay? And it makes a difference whether that 2 is inside or outside the parentheses. In other words, it's very important that this be your standard right there, because not every school has that as a standard. Some schools put the B inside the parentheses, and it changes everything. In other words, some schools have their standard like this. See what I'm writing? Notice the difference? And there's a huge difference in how phase shift is defined, and well, that's the main difference. So you have to make sure we're dealing with apples and apples here, not apples and oranges. In other words, I don't want to teach you the top format if the format they teach you in your class is the bottom one. Okay. So that's going from a graph to a function. And I think you can go backwards. Well, let's go backwards. Or do you have some problems? Yeah, do you have some? That's the best way to do it. How about we start with you read the function and we'll graph it. Because it's going to be hard to go the other way because you're not going to be able to verbalize that. But you can verbalize the function and then we can go about graphing it. Doesn't have a function? Okay. I can make up some if you like. Or you can take a picture and send it to me really quickly. I think I can make stuff up that'll be just as good for you. Okay, let's talk about that for a second. Well, it is a little weird. It's because even though it's called a sinusoid function, that can be sine or cosine. And it's still, in other words, if I put cosine in there, it's still a sinusoid function. The difference is cosine looks like this, and sine looks like this. Unshifted. Neither one of them is shifted. And both go to 2 pi. So the B is the same definition in either case. The bottom one is the sine function unshifted horizontally. The top one is the cosine function unshifted horizontally. Now notice what would happen if I take the top function and move it to the left by pi over 2. No, excuse me. I move it to the right by pi over 2. It becomes the sine function, right? In other words, if I take this top function, here, let me use a different color just so you can see what I'm doing. And I'm going to move it to the right by pi over 2. It then becomes this, right? In other words, I've taken this point right there and moved it that far to the right, which happens to be pi over 2. So if you take a sine function or a cosine function and move it to the right by pi over 2, you get the exact same thing as a sine function. And in fact, if I take the sine function and move it pi over 2 to the left, I get the exact same thing as the cosine function. So the only difference between sine and cosine is a horizontal shift by pi over 2, one direction or the other. And that's why this function can apply to either sine or cosine, because they're really the same thing, only one is shifted from the other. It's a little hard to understand, and that's not really where we should start this conversation. Let me do some things. I'm going to draw some graphs here, and we're going to figure out what the equation of it is. Think for a second here. One thing you end up doing in trig a lot is quartering these things up. In other words, if you know where the end of the period is, find the 4 quarter marks like I just did. You with me? Okay. Now this time, I'm going to vertically shift it. And the way I'm going to do it, it's supposed to be a dotted line, is like that. I'm going to take the curve and I'm going to move it up. In other words, I'll start with a sine curve. This thing is best taught one thing at a time, not all four things at once. Do you know what I mean? In other words, I really want to teach you one thing at a time. So let's, in this case, I'll do two things at a time. But let's go up to 3. Let's go down to -1. And I'm going to start at 1. And I am going to do this. And our job is to figure out the equation of that curve I just wrote. So let's start with A. What's A? What's the formula? It has to do with maximum and minimums. What's the formula? What's the verbal definition of A? Okay. Which is 4 divided by 2, so A is 2. What's the next letter that's most easily found? Similar to the D, okay? What's D? You know, it's the opposite, so it's not the minimum minus the max. It's not the maximum minus the minimum. What is it? It's the maximum plus the minimum divided by 2. Okay. B. What's the definition of B? What's the period here? Good. So what's B? Simplify it. Okay, that's 1/2. And finally, C. What is C here? And it depends. Actually, to answer that question, you need to know whether I'm going to use sine or cosine. I'm going to use sine. So if I'm going to use sine, what is C? Okay, so what's the equation of this line? Oh, there's a D. We found a D of 1 plus 1. Plus whatever this D over here is the same as this D up there. So that's the equation of that line. Now, let's say the question is, I don't want the sine function, I want the cosine function. Now, what's A if I'm talking cosine function? Still 2. Still the maximum minus the minimum divided by 2. What's D? Correct. What's B? Okay, the only thing that's different is C. In other words, how much and in which direction if I want this to be a cosine curve, it's got to start right there and end right there, right? You can see that its period is still going to be 4 pi. It's going to, instead of going from 0 to 4 pi, it's going to go from pi to 5 pi. That's still a period of 4 pi. So b is still the same. It's still 1/2. b is always 2 pi divided by the period. You read the period from the graph. The only thing that's different is the phase shift, the horizontal shift. What did I have to do to this original red curve in order to get, let me make it not orange, won't be able to see that, green. Here's the green curve. Starts there, goes down, all the way to there, goes back up, all the way to a starting point again. How is the green curve shifted relative to the red curve? How far and which way? Correct? By pi? Actually, yeah. No, you're right. The green is shifted. No, it isn't. Why am all of a sudden I'm having a brain lapse here? Because I haven't done trig in a while. Let's see. If I take the red curve and I move it, oh, I see what's going on. I have to move the red curve to the left if I want the green curve to start out at the origin. So I really have to shift it by pi to the left, which makes this a minus pi shift. So if I want to define the green curve, I can do it down here at the bottom. It's still 2, but this one's cosine of 1/2 x minus pi plus 1. And there you have a curve that has all 4 things going on to it. And incidentally, there is also reflections. The same way that you have 2 reflections with algebraic equations, with polynomials, you can have 2 reflections with sinusoid. And by that, I mean, this is why it's so important to memorize what your basic function looks like. Okay? There's your basic sine and cosine. Be able to draw those in your sleep. So, if that is y equals sine x, how would I draw y equal negative sine x? What's that negative sign mean? It's a reflection over which axis? Correct. So if I reflect that original curve, looks like that. Notice that if I want negative cosine x, that would be a reflection over the x-axis also. What would, here, let me change this just a little bit here for a moment. Which axis is that reflected over? Nope. Remember the negative sign is inside the function. In the top right, the negative sign is outside the function. That makes it a vertical reflection. In the bottom right, it's a horizontal reflection. So if I horizontally reflect this curve, not this one here, we're done with that one. If I horizontally reflect the sine x curve, looks like this, right? Exactly like that. And if you continue drawing it, also looks just like negative sine x. And sine of negative x is equal to negative sine of x, so it should look like it. So in addition to A, B, C, and D, you can also have two different negative signs. In other words, the same horizontal and negative, or horizontal and vertical reflections that you get with polynomial equations. I'm still a little mystified as to why mathematics does not teach this in the same vein. They don't use the same words or anything as they use in transformations. You know, transformations, it's vertical stretch, vertical shift, horizontal stretch, horizontal shift, and reflection over the x-axis, reflection over the y-axis. Those 6 terms. Yet almost none of them are the same. And dealing with trig functions, they use amplitude, B, which is 2 pi over the period. They use C and they call it phase shift. And they use D and they call that vertical shift. That's the only thing that's the same. But they really are the same things. Okay? So, you need to be able to go both ways. You need to be able to take a graph, turn it into an equation, and take an equation and graph it. Since the only thing we can really do online without a picture is to graph an equation. Actually, you know what? I can find some. So I got plenty of material here. Let me find some. In my online, I got lots of I got plenty of graphs here we can look at, I think. Sinusoid, this one right here. Let's see what this looks like. Yeah, perfect. Number 10. They've given us a graph, and they want us to tell us the sinusoid function for that graph. So, where do you start? A. In other words, you start with trying to solve all 4 letters. If you've solved all 4 letters, you got it done. That's all there is to it. So what's A? That's correct. Oh, shoot. When I did that, it screwed everything up. Okay, let me try this again. A is 3. B. In order to find B, we need to know the period. What's the period here? Remember, it's this. Yes. So instead of B, let's write the period, because that's what we can tell off the graph. Now, what does that make B? Because B is 2 pi over the period. Okay, good. So that's the way you always solve for B, is you find the period, and then you solve for B. B is 2 pi over the period. Okay? Is there any phase shift? for a sine. If we're going to use sine, no, there isn't. Sine starts out at the origin, goes up. Okay, so C is 0. D is what? I should have done D second after A, but that's okay. Okay, yeah. And one way to think about D is, has this thing been shifted up or down? No, it is perfectly symmetrical about the x-axis. So it has not been moved up or down. So we have A, we have B, we have C, we have D. What's the equation of this line? Yeah, I don't need the parentheses if there's just x there. If there is a phase shift, then I do need it. But since C is 0, it's 2 times the quantity x minus 0. And that's it. It's that easy. Let's try another one here. Okay. Number 12. Hold on 1 second. What's D is what? What's D? D is the vertical shift. Okay. What's the period? Let me write it like that. Yep. No. Well, the period is 4 pi. In other words, the period is from there to there. Another way to measure it is from there to there. In other words, sometimes you don't always have 2 perfect points. So the period is the distance between when this thing starts all over again. Okay, so it's peak to peak, it's valley to valley, it's that point to that point. No matter how you measure it, it's 4 pi. So now we can figure out B, now that we know the period. What's the period? B. What is B? Good. And what is C? So what's the function? As a sinusoid function. That's it. Let's see if I can find one a little harder here. Yeah, this one's a little more difficult. Now, there's 2 ways to look at this problem. So let's talk about if they don't tell you whether they want a sine or a cosine, you generally use whichever one has the least phase shift. Okay, you got it? That's the rule. If I use a cosine function instead of a sine, this has no phase shift. Notice what the cosine function looks like. Cosine function looks like this. Well, that's pretty close to what we're looking at. What is it? What we're looking at is the reflection of the cosine curve over the x-axis, right? So we still need to figure out A, but what we know is that we're going to use the cosine curve and we're going to put a negative sign in front. Let's just go through the process and you'll understand. What is A? What is D? What is B? What's the period? Two pi. So what is B? And what is C? Just for the moment, take my word, there's no phase shift. Okay. So our function would be what? Hold on. Let me write it right here. 5 equals 5. It's not sine, though. It's cosine, right? Of what? Is there any phase shift? Okay. The only problem, what we're missing is a negative sign. In other words, remember what we're looking at is the cosine curve reflected over the x-axis. Well, the way you get that is with a negative sign in front of the function like that. So this is the answer, minus 5 cosine of x. Notice that what I have up here in the upper right, that's plus 5 cosine of x. As long as it's going from 5 to negative 5, that's what that curve would be in the upper right. The only difference between the curve in the upper right and the curve in the problem is it's been reflected over the x-axis. That, we know, equates to a negative sign in front of the function. In this case, in front of the 5. Okay? All right. Ooh, don't want to do that. Hold on. May have to do that. Let's see. Yeah, let's open up another one here. Let's try this one. All right. 15 appears that they've given us both the equation and the graph. So what could they possibly be asking us for? I don't know. On 15, 16, 17, and 18, what they're doing there. Let me open up a different one here. Same thing. Now, specify the period and amplitude of each function. All right. Number 13. What's the amplitude? What's the period? Remember, what's B equal to? No, 2 is B. So, yeah, in other words, that's what they're asking for, is what's the period? Well, let's see. The period is equal to 2 pi over B, right? So what's the period? Correct. And what that means is that this point right here is at pi. Because that's where the function starts over again. It starts there, restarts right there. And since we know by our calculation that the period has to be pi, that's where pi falls on that curve. Notice they didn't label the x-axis. They didn't do it on purpose. Okay, on number 14, what's A? Okay, what's the period? Okay, no, hold on, no. First of all, let's write the general formula. B is 2 pi over the period, right? So the period has to be 2 pi over b. We know b. What's b? So what's the period? Two pi over 3. Exactly. That's why you have to really memorize what b is. B is 2 pi over the period, and sometimes they want the period, which is 2 pi over b. Stop writing on it. This is going to be something a little different. This is going to be like a word problem. Yeah. There's tons of things in life that follow the sinusoid function. And I mean tons, thousands of things. Let me name a few. The tides. High tides and low tides. That follows the sinusoid function. Daily. Period is 1 day. Breathing. How many seconds do you think it takes you to breathe where you empty your lungs and then fill them again and then empty them? Give me a guess. What do you think that period? Go ahead and try it right now. Take a breath in, blow it out. How many seconds does it take? Yeah, maybe 4 or 5. So the period would be 4 or 5. And you do exactly the same thing. You blow out a certain amount of air, you inhale a certain amount of air. So if I'm graphing your breathing, it looks just like, this way, sorry. How does it look? Looks like this. You start with medium full of air in your lungs. You breathe in. You have your lungs full right there. You breathe out and you expel all of the air and you're down to there. And you breathe in again. Same thing over and over and over and over. So breathing is a sinusoid function. The seasons are a sinusoid function. If I go out to a river and I got a rope hanging from a tree and I swing out on an inner tube over the river, that's a sinusoid function. If I have a tuning fork and I click it, that's a sinusoid function. I mean, literally thousands of things follow this sinusoid function. And you can take models that are word problems and come up with what the sinusoid function is, merely by looking at what's the maximum value, what's the minimum value. That'll give you A and D. You can figure out phase shifts and periods based on the table. That'll give you B and C. You got your sinusoid function right there. So all of these problems that you see up here, that's what they're doing, is they're giving you something that the annual temperatures for a year, if you think about it, that just fluctuates, right? In other words, January to June is the hottest month, and then next June is going to be the hottest month, and the June after that's going to be the hottest month. Follows the same period every year with some variation, but it can still be approximated by a sinusoid curve. All right, let's see. What can we do next for you? Let's talk about vectors. Okay, here's what they're talking about. First of all, I can't remember the movie, but it was about a vector called E. It was an animated Disney movie about 20 years ago. You know what I'm talking about? Okay, but anyway, he's a vector, and he says, I have both magnitude and direction. If I measure the length of a table and I get 3 feet, that's magnitude only, right? There's no direction involved in that at all. That's magnitude only. If I have the measurement of a table and it's exactly 3 feet, that's magnitude. No direction there. But if I have an airplane flying like that, 30 degrees north of east, that's east, that's west, that's north, that's south, and this airplane is going at 500 miles per hour, that's its magnitude. So when you are talking about vectors, you're talking about two things. You're talking about the magnitude of the vector, and you're talking about its direction. In this case, 30 degrees north of east. Now, what kind of things are vectors? Well, two primary things are usually expressed as vectors. One of them is the speed of a moving object, like an airplane or a car or a rock that you throw. Both of them have a speed and a direction. The other thing is forces. If I pick a 10-pound rock up from the earth, I am applying 10 pounds, that's the magnitude, worth of force in a direction straight up. That's what vectors are all about. Now, there's a lot more to vectors than that, unfortunately. But we had a lot to cover tonight. You can't really cover sinusoid functions and vectors in an hour-long session. But the main thing, another way of thinking about vectors is, say I have a vector 3, 4, like that. Or it's not those signs, it's a sign like that, I think, isn't it? That means vector. Well, one way to look at that vector is I'm going to go 3 units along the x-axis, I'm going to go 4 units along the y-axis, so I'm going to end up there, and if I draw a line to the origin, that's that vector. And it is the point 3, 4. Well, what's the magnitude of that vector? It's 5, right? That's a 3, 4, 5 right triangle. So the magnitude is just like the Pythagorean theorem. It's the square root of the sum of the sides. The sides being 3 and 4 in this case. In other words, this point down here is 3, this point up here is 4. That's a 3, 4, 5 right triangle. That magnitude is 5. What's the direction? Turns out that that angle is a 53-degree angle approximately. So you could say that that's a vector of magnitude 5 and a 53-degree angle. But just remember, vectors always have magnitude and direction, not just magnitude. So many other things have just magnitude. If you're weighing a watermelon, you get 10 pounds. That's magnitude only. If you're measuring how tall you are, you get 5 feet 10. That's magnitude only. But if you're applying a force to a sword in a rock, the sword and the stone, you're applying a force of some amount at some direction. And it's not always straight up. Might be sideways. But it's some direction. So that's the most important thing to learn about vectors, is that they have both magnitude and direction, and they can be expressed as their x and y components. And let's end it there. As I said, I could spend a whole nother hour on vectors, but and they can be tricky. I never liked vectors when I was in school. I always found them puzzling. I understand them a little bit more now, but they can be tough. They're one of the tougher areas of pre-calc. Yeah. All right. You good to go, Brandon? Okay. You have a good one. If I don't talk to you again, have a Merry Christmas. And maybe we'll talk to you next year, or even again this year if needed. So, all right. Have a good one. Bye-bye.